All right, everyone. So the problems that were requested today are to do homework 9, problems 2 and 3. So I'm going to go ahead and get started first on this problem, problem 2, where we're given the equation y double prime minus y prime equals 2 minus 2x. So I've written that here. And whenever we start one of these non-homogeneous problems with a function on the right side, our first step is actually to solve the homogeneous part where we have y double prime minus y prime equal to 0. We're going to need our general solution for that equation. And so this is a constant coefficient equation. That means that we solve it by assuming that y is e to mx, which means y prime is m e to mx, and y double prime is m squared e to mx. That's just taking that derivative 3 times. And then we plug this guess into our differential equation and find out what m has to be. So for us, that's y double prime is m squared e to mx, and y prime is m e to mx. Should be equal to 0. So I've just kind of matched those parts there of the y double prime and y prime. Some of you all try to guess what the auxiliary equation is going to be, and you sometimes miss terms. So doing it the long way is showing all the work, so you get partial credit if you do get it wrong, and also make sure that you don't miss anything or accidentally put your m's in the wrong place. So since it's equal to 0, I know that I can divide out that e to mx. And then if I factor this, I get m times m minus 1, which means my two roots are 0 and 1. So my two solutions would be e to 0x and e to 1x. And then just one important thing to note is that e to power 0 is just 1. So this is actually y1 is 1 and y2 is e to x. So if I hop back over to the web work, we're asked first to write the auxiliary equation. So that's going to be this function that we get after all the e's go away. And it's just going to take r's instead of m's in web work. And then it asks for the roots, so that's going to be this part right here when I solved for what my zeros are. And then the fundamental set of solutions is going to be that y1, y2 that we found right here. So that's 1 and e to x. And so those first 3 parts are kind of like stuff that we already knew how to do, but we need it to finish the rest of the problem. So now we move to the problem of trying to find yp, the particular solution, when we are trying to solve y double prime minus y prime equal to minus 2x, I think it was. Yes. And so when we do this type of problem, our approach is sort of like there's 3 parts. So what is the right side of the equation? What I've called f right here. Make sure to include all the derivatives, and then deal with any repeats. So the functions that are in my f are 2 and minus 2x. To make it easy on me, I like to ignore extra constants, so that's really just 1 and x. So my thought would be that my particular solution takes the form a, that's 1, plus bx, that's the x. Then I check, did I take care of all the derivatives? And in this case, yes. I have down to the last derivatives. X goes to 1, 1 goes to 0. So since I already have my 1 function and my x function, there's nothing new for me to add. And then I have to check that I haven't had any repeats of functions. So my y1 was 1, and my y2 was e to x. I go back and check the solutions to the homogeneous equation, the one that's equal to 0, and I make sure that my yp doesn't repeat those functions. Unfortunately, I have y1 equals 1, and I built my function with a 1 right here. So our solution is always to multiply by x when that happens. So here I've multiplied by x to make the a no longer a 1, but that's still a copy of my bx right here. They're the same thing, so I actually multiply by x again. I keep going until I have a new function that's not already part of one of my solutions. And then this yp right here is going to be the one that we go forward with plugging into our differential equation to solve for a and b. So my yp is ax squared plus bx, and my equation is 2 minus 2x. So to plug this in, I'm going to need the derivatives. So the first derivative is going to be 2 times ax plus b, just taking that power rule. And my second derivative is just going to be 2a. Now it is important to remember to hold on to constants when you start taking derivatives that come from your power rules. If you don't include those, then your whole equation can get unbalanced. And then when I plug this into my ODE, I've got 2 minus 2x is supposed to be equal to yp double prime minus yp prime. But for me, yp double prime is 2a, and yp prime is that 2ax plus b. And I'm going to multiply that negative all the way through just so that I don't lose it later. Then to try and solve this one equation for 2 unknowns, what I do is I group my like terms, the things that are different powers of x, in order to get like 2 sets of conditions. So I've got 2 is multiplied by 1 minus 2 times x on the left side. And then my constants on the right are 2a minus b. That one's multiplied by 1. Plus negative 2a multiplied by x. So all I did was I grouped these constant terms together right here. And now I just set them equal based on matching the 1 or x. So 2 should be equal to 2a minus b, and minus 2 should be equal to minus 2a. By pairing this and this, and then this and this. So solving those equations, I'm going to get that a is equal to 1 from the bottom equation. And then plugging that 1 into the first equation gives me that 0 is equal to minus b, or b is 0. So I think my yp is just going to be 1 times x squared plus 0 times x, or x squared. So let's submit that. Okay, cool. So that's correct. And now the last part is that I have to find a solution to the IVP for y of 0 equals 3, y prime of 0 equal to 1. Sorry, I was just copying down the problem again. Oops, I messed that up. 2 minus 2x. So I'm trying to solve this problem right here. And I need to plug in my solution that has both the general and particular parts. So first I used my y1 was 1 and y2 was e to x to fill in the general part with the unknown coefficients. So that's c1 times 1, or just c1, plus c2 e to x. And then my yp I just found to be x squared. So I also put that in. And then this whole function y is the thing I have to plug into my ODE. My initial value problem to solve for my unknown coefficients. So since this is a second order equation, I have a condition on y and a condition on y prime. So I'm going to go ahead and compute y prime as well. So my c1 goes away, and I'm just left with c2 e to x plus 2x. And I'm going to have to evaluate these at 0. So I've got c1 plus c2 e to 0 plus 0 squared, and c2 e to 0 plus 2 times 0. Simplifying those, I'm going to have c1 plus c2 and just c2. Then my conditions where y of 0 equals 3 and y prime of 0 equals 1. So I'm just going to set that equal to the values of my function when I plugged in 0. And that gives me a system of 2 equations with 2 unknowns. And I just got to solve for c1 and c2. So I'm in luck. I already know what c2 is. It's 1. And then plugging that into my first equation tells me that 3 is equal to 1 plus c2. Oops, sorry. c1 plus 1, because I already found c2, not c1. That's my mistake. Which means that c1 is 2. So my solution should be y is 2 plus c2 is 1 e to x plus x squared. And let's go ahead and plug that in and see if it's right. And it is. So that's how we do that problem. The next problem that was requested was problem 3. So I'm going to write that down real quick. Y double prime plus y prime minus 12y is equal to 98 times 2x plus 1 e to minus 4x. All right, so this one looks more complicated, but we're still going to start the exact same way, where we try to solve the homogeneous problem first. Y double prime minus y prime plus 12y equal to 0, where we assume that y is e to mx, y prime is m e to mx, and y double prime is m squared e to mx. So that's going to give us m squared e to mx minus m e to mx minus 12 e to mx is equal to 0. Or, dividing out that e term, m squared minus m minus 12 is equal to 0. And that's my auxiliary equation, the thing that I'm going to have to plug into that first box on WebWork. But I'm going to have to solve for m, so I'm going to try to factor it. And since I see a 12, I know that I could have like 4 times 3 or 6 times 2, but I want things that have a difference of 1. So I picked to have minus 4 and 3 because minus 4 times 3 is minus 12, but minus 4 plus 3 is minus 1. And so my roots are going to be 4 and minus 3. So I'm going to check that those are right real quick. M squared minus M minus 12, 4 minus 3. Oh no. R squared minus R minus 12. No. Oh no, I calculated my equation wrong. What did I do wrong? Oh, it's supposed to be plus y prime here, so plus m e to mx there, plus m. So it's just the opposite factoring, m plus 4 times m minus 3 gives m equal to minus 4 and 3. So what I did was when I started doing the problem, I copied down my question wrong. Those of you who work on things in class should be used to by now that when I come by to help you with a problem, usually the first thing I check is that it was copied down right, because that's a really easy mistake to make. And I make it all the time. So I'm just going to fix those signs real quick. And cool, I got those answers right this time. So then we're asked for the fundamental set of solutions. So remember, we assumed that y was e to mx. So my y1 is e to minus 4x, and my y2 is e to 3x. Just plugging in those roots that I found. And those are correct as well. So we can go ahead and continue to the last part, the thing that's new, where we're going to try to find the particular solution for this very long differential equation. So let me copy that down correctly this time. All right, so that's my function. 98 times 2x plus 1 e to minus 4x. If you wanted to kind of see it multiplied through, it's 98 times 2x e to minus 4x plus 98 e to minus 4x. And I'm going to ask myself those same three questions. What's in f? What are the derivatives? And do I have to deal with repeats? So just focusing on the functions, not on the constants, I've got x e to minus 4x and e to minus 4x in my function. So my first guess would be that yp is a times x e to minus 4x plus b e to minus 4x. This first guess is always going to look like whatever your function is over here, just with a and b instead of any numbers that your problem has. Then I got to check for derivatives. So x e to minus 4x derivative on prime is like e to minus 4x minus 4x e to minus 4x. So it's e and x times e. And e to minus 4x prime just gives you minus 4 e to minus 4x. So again, an e. So since I'm already seeing that e to minus 4x and x e to minus 4x that show up in all my derivatives, I know that I don't need to make any changes. So my yp is still ax e to minus 4x plus b e to minus 4x. And now I'm going to check for repeats. So my y1 and y2 came from the previous part. They were e to minus 4x and e to 3x. That's what I got at the end of the previous page. And so here I can see that I'm going to have problems with e to minus 4x because it's part of my solution, so I have to get rid of it. So I take the approach of multiplying by x. Now I've made it different from e to minus 4x, so that's good. But it's the same as the x e to minus 4x I already had. So just like last time, I need to multiply by x again to get a new power and a completely different function than anything else that's in this equation. And that's what I'm going to continue the rest of the problem with. So I've got yp is ax e to minus 4x plus bx squared e to minus 4x. And I'm going to be plugging into y double prime plus y prime minus 12y equal to 98 times 2 plus x e to minus 4x. Let's see what I have to change. Plus y prime minus 12y, 2x plus 1. Okay, that looks right to me. Wanted to give it one more look so we don't do all this algebra for no reason. All right, so my equation has y double prime and y prime in it, so I have to take my derivatives of yp if I'm going to plug it into this equation. So I just did with the product rule previously that the derivative of x e to minus 4x is 1 times e to minus 4x. That's taking derivative of x. Plus x times minus 4 e to minus 4x. That's taking derivative of e to minus 4x. And then similarly, I'm going to have 2x is the derivative of x squared e to minus 4x plus x squared times minus 4 e to minus 4x. And I'm going to go ahead and x squared. I'm going to take this derivative and then I'll group like terms next line. I don't think it's going to add a whole lot for me to group them now. So I'll just hold off on it for a second. So derivative of e to minus 4x is just minus 4 e to minus 4x. And then derivative of this x times minus 4, just threw my pen, e to minus 4x is going to be minus 4 times the whole derivative I got of x e to minus 4x last time. So derivative of x is 1 times e to minus 4x plus x times minus 4 e to minus 4x. And then for b, I've got 2 times same derivative, 1 times e to minus 4x plus x times minus 4 e to minus 4x minus 4 times the derivative of x squared is 2x times e to minus 4x plus x squared times minus 4 e to minus 4x. So it's just repeating a bunch of product rules. And then we're going to have to start trying to simplify things. So I've got minus 4 e to minus 4x minus 4 e to minus 4x plus 16x e to minus 4x times a. This term stayed the same. And then I distributed my minus 4 to both those terms. And minus 4 times minus 4 gives me positive 16. Then I'm going to have 2 e to minus 4x. I'm distributing this 2 through. Minus 8x e to minus 4x because 2 times minus 4 is minus 8. Next, I distribute this minus 4 times 2, I get minus 8x e to minus 4x plus 16x squared e to minus 4x. Again, because this minus 4 times minus 4 gives me positive 16. All right. So I've got combining terms inside, minus 8 e to minus 4x plus 16x e to minus 4x plus b times 2 e to minus 4x minus 16x e to minus 4x plus 16x squared e to minus 4x. And let's see if I can lasso only the parts I want to keep over to the next page. So I want my y and my equation. And my yp prime. And my yp double prime. But everything else is just kind of a distraction for me right now. So let's see how much of that comes with us. Okay, that's pretty good. I lost my x right there. But otherwise things are looking pretty good. I know that eventually I'm going to have to group all my like terms in x squared, and just regular e. But I think I'm just going to plug it all in and then do that grouping later, because these equations are just so long and messy. So I'm trying to plug in yp double prime plus yp prime minus 12yp. So I'm going to take my yp double prime. I'm just copying it down right now. Sorry, my dog's unhappy about something. Plus my yp prime. Again, I'm just copying it down. Minus my 12 times yp. And I went ahead and distributed that minus 12 to both terms of my yp, just so that I wouldn't have to copy all this down on a whole other line just to do that multiplication. And now I need to group like terms in functions of x. So I need to know my e to minus 4x terms first. So let's see about maybe just highlighting them. So there's an e to minus 4x, there's an e to minus 4x, there's one, and that's it, I think. So I've got minus 8a from my first term, plus 2b from my second term, and plus a from my third term. I'm just looking at a times whatever number, b times whatever number, a times nothing. And then let's go ahead and do my x terms now. So I've got this term, that one, and that one. So things that just have x e to minus 4x, but not x squared. So I've got 16a minus 16b minus 4a plus 2b minus 12a. Okay, and I can see that that's going to simplify nicely for us, but I'm going to wait until the next line to do it because I don't want to forget to do my x squareds. So then my x squared terms, what's a color that's kind of different now? I guess this purple should be different. We'll hope for the best there. There's an x squared, there's an x squared, and there's an x squared. So I've got 16b minus 4b minus 12b. Okay, and now I want to point out real quick that when I do 16 minus 4 minus 12, that's 0. Yeah, and then same thing here, 16a minus 4a minus 12a, that's also 0. So what I'm left with in these functions is e to minus 4x times minus 7a plus 2b plus x e to minus 4x, which is minus 16 plus 2 is minus 14b, and then plus x squared e to minus 4x times 0, so that just goes away. Now, the whole reason I was doing this was to plug it into this equation right here. So I'm going to go ahead and do that on the next page. I want this all to be equal to 98 times 2x plus 1 e to minus 4x. And then I had minus 8a minus 7a plus 2b. Plus x e to minus 4x times minus 14b. Okay. And then before I continue, I just want to make sure I've got this right side right. 98 2x plus 1 e to minus 4x. Okay. Then this is 196x e to minus 4x plus 98 e to minus 4x. Just multiplying that 98 through is equal to minus 7a plus 2b. Oops. I'm going to swap these so that the order matches what we're seeing on the left. So minus 14b x e to minus 4x plus minus 7a plus 2b e to minus 4x. So then, setting like terms equal on both sides, I'm going to have the two equations that 196 should be equal to minus 14b okay, and 98 should be equal to minus 7a plus 2b. Okay. Sorry, I'm just having trouble because I know that this isn't going to be a nice number, so I'm already wondering if I did something wrong. But I should just trust the process and see what happens. So I'm going to get b is 196 over minus 14. And I don't want to figure what that is. But it does mean that 2b is going to be 196 over minus 7. And I'm going to have to plug that in the next equation. That's what I wanted to know, what 2 times b is. Just the 2 eats part of the 14 and leaves 7 behind. That means that 98 is equal to minus 7a plus 196 over minus 7. Okay, so 98 is 49a plus 196 over minus 7. Which means A would be that thing. I don't think that's getting especially nice looking. So yeah, I'm not going to go ahead and try to simplify that. I guess I could try to pull out the common 7 at least. Okay. Well, that's what I got algebraically. And I'm going to go try plugging that in. Remember, I had a times x. So that's minus 126 over 7, x e to minus 4x plus b. So minus 196 over 7, x squared e to minus 4x.